5, last section in the chapter, so we will start chapter review tomorrow, is measures of position. So we did measures of center, measures of variability. Now we're doing measures of position. So again, some of this might be something you've already done, which is great. Some might be new. So, quartiles. You are splitting your data into 4 equal sections. Okay? So, your median already splits it in half. So that's considered your second quartile. Because you're going to have 25% here, 25% here, 25% here, 25% here. So your median is actually 50% of your data up to that median. So that's considered your second quartile. Then all you're doing is you're taking the numbers below the median and finding that median. The median of the lower set is your first quartile. The median of the upper set is your second or third quartile. So they're not hard to do. You're just doing medians again. So you take your data, make sure it's in order, find your median. Then go to the left of your median, find that median. Go to the right of the median, find that median. Okay? This creates your 5-number summary. So the min is your first number. Your first quartile is the second. The median or the second quartile is your third number. Third quartile is your fourth, and then the max is your 5th number. So this is called, bless you, 5-number summary. Okay? So quartiles, not hard to do. Find the median. Go to the left of the median. Find that little subset's median. Go to the right of the median. Find its median. So it's all about the medians. Okay? Remember, if you're between 2 numbers, you have to add them together and divide by 2 to find the median. Okay. All right, so each year in the U.S., automobiles, commuters waste fuel due to traffic congestion. The amounts of fuel in the largest 15 U.S. urban areas is listed. Find the first, second, and third quartiles in the data set. What do you observe? So, first thing you have to do is put them in order. All right. So, this is the ordered set, maybe. All right. So, how many numbers do we have here? 15? So, how many should be on either side of the median? 7. So, 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. This is the median. There's 7 on either side. So that's my Q2. So I have 7 on either side. How many's on either side of that side? 3. So 1, 2, 3. 1, 2, 3. So this is my Q1. This is my Q3. Okay. Easy enough? Nothing crazy? We can all do that. Okay, and again, the observations, what you're observing. You can say the middle 50% of the data, understand each set of this is middle 50%. Each set's 25, represents 23 through 30. There's different things you can observe. Okay? All right. Use your calculator. So this is a bigger list. Do you really want to have to reorder it and do all this? So I'm going to show you on your calculator. But again, on the test, you're going to have to do it by hand. So make sure you know how to do it by hand. Okay, so go ahead and your stats and type this list in. And it doesn't have to be in order. Put that up so you can see it with my calculator. remember, you're supposed to have 25 numbers. So at the end, if you look down, it says L125. That tells you you have 25 in your set. Okay? So, here's one thing you can do. Has everyone got the numbers in? This will help you like on your project and different things. You can go back into Stat, and you can sort. So what it'll take is it'll take that list, and you want list, I put it in list 1, so second 1 brings me up L1, and just hit enter, and it doesn't look like anything happened, but if you go back into Stat and edit, my list is now in numerical order. Okay, so that's nice. If you have 70 things in your project and you want to put them in order, type them into your Stat and let them get ordered, okay? So that's one thing. So you're going to go to Stat, Sort. Sort A means ascending, so from little to big. Sort D would be big to little. And then you have to tell it what list you used. So if you used L2 or L3, whatever your column title is. So make sure you're looking at that. Some of you guys might have deleted a list. Okay? Make sense? All right. So we've done that. Ready? Go back to Stat. We want to calculate one variable Stat because you've only got the one column in there. And just hit enter. Make sure it's the column you want, L1. We did this yesterday. So this is giving us our mean, right? It's giving us a bunch of stuff. Standard deviation for the sample, standard deviation for the population. N means how many numbers in our data set. We have the min. You see the little arrow that's pointing down? So there's our 5 numbers. Min, Q1, median, remember, is Q2, Q3, and your max. Okay? So your calculator can do that for you. You still need to be able to do it by hand. This is just for your reference. Okay? Everyone able to do that? Okay. We good?
Rewrite it as Q2 or median?
Either one is fine. Okay. Alright, moving on. Box plots. So the box and whisker plot is the 5-number summary graph. Okay, it's the display of the 5-number summary. So what's important with box and whisker is you have to have an evenly distributed number line. Okay, you can't just bunch it together because you're box and whiskers. So this has to be put with an even scale in between. Then you put your numbers in for your box and whiskers. So we need a min of 5. So we're going to put a dot there. Q1 of 9, 13.5, 23, 32. You put a box around the middle 3. Draw a line intermediate, and then the whiskers are from the min to Q1 and the Q3 to the max. And this shows you how your data is distributed. You can see that it's more spread out in that 3rd quartile and the last quartile, right? It's more spread out. Here it's pretty evenly distributed in the first 2 and evenly distributed in the second 2, but then they can ask you questions like, what percent of the data is from 9 to 32? What percent of the data lies between 9 and 32? 75. Each piece of this box plot is 25% of the data. So if we're going from 9 to 32, 25, 25, 25. Good, okay? Can we do that? Easy enough? All right, let's try one. What's the median number of goals? 6. What's the range? 10. Range is just high minus low. What's the percent of games from 5 to 11? 75. We kind of did one like that already. All right. Interquartile range. So when they talk about IQR, interquartile range is just the range of the quartiles. Q3 minus Q1. The inner range. It's the length of the box. This is the interquartile range. The middle 50%. Okay? We need that number to do our next thing. Okay. So, identify the range. This is kind of hard. These are going by twos. That's 52, 54, 14, 54, 14, 40. By the way, Browns, not even on this. I think the Steelers were on there probably, what, 5 times? All right. Interquartile range. What's the interquartile range? That's like right in the middle. So 38 minus 23, maybe? 24? We're estimating. So 14? 14 to 38. What percent of scores between 14 and 38? 14's here. So 38's here. 75 again. All right. Outliers. So when we talked the other day, we said they look like they don't belong. This is the actual mathematical way of finding if they belong or not. But sometimes they're on the edge and you don't know. Okay? So, first thing you have to find is your quartiles. So, how many of these did we say there was here? 30? There's 20 movies here. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is in between 101 and 92. Right? So we have to have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So the Q1 is between 65 and 66. What would that be? 65, 66. 65.5. All right. The lower set, 1, 2, 3, 4, 5. It's between 122 and 131. So how do we find that if it's two numbers? So we can't just look at it? Add them together. So 122 plus 131 divided by 2. I can't do it in my head today. It's just too tired. 126.5. Okay? So 126.5 minus 65.5 gives me 61. That's my interquartile range. Everyone follow? You take the interquartile range, whatever it happens to be, and multiply it by 1.5. This is considered, I consider it the magic number. It's the spread that's allowed to find your extremes. So you take your Q1 and subtract that number from it. You take your Q3 and you're going to add that number to it. So we're finding the extremes from the end of the box. Not the end of the whiskers, into the box. So we've got 65.5 minus, that's going to give me a negative number. Obviously I don't have a low extreme. I'll find it anyway, but it's negative. Then you're going to start at the high quartile, the 126.5, and add it again to that one. And you get 218. So basically anything under negative 26 is an outlier, which we don't have any because there's no negatives. And anything above 218 is an outlier. So do we have anything above 218? Yeah, these guys. Remember The Lion King and Forrest Gump? Those movies? So those would be considered outliers. Okay? So you find your interquartile range. You're going to add it to the low, Q1. I'm sorry, you're going to subtract it from Q1, add it to Q3. That's your band you're looking at. Anything outside of that band is bad. Good. Okay. You guys try this one. So, for this one, go ahead and put the data set in your calculator. Practice getting those quartiles. That's not really a good question to ask in here. Practice getting your quartiles with your calculator. Find your IQR and what's Q3? 63? What's Q1? 57? So 6 is our interquartile range, yes? And we're going to take the IQR and multiply it by, that's just the rule, right? It's always 1.5. So there you get 9. So 57, we're going to go 9 this way, which would put me where? 48. And then I'm going to start at 63. I'm going to go 9 this way. 72. So this is our good numbers. Anything outside of those is an outlier. So do we have any outliers? 80 is it, right? Okay. So it's better, always better to put them in order though. Because then you can see the outliers better. Because there could have been another one hiding in there, maybe you didn't see. So put them in order of that calculator, and then you can see where 58 is and 72 is in the order. Okay? So you're subtracting it this way, you're adding it this way. Good. Alright, let's move on. So percentiles and other fractiles. Percentiles is really the main one. Quartiles and percentiles. I don't know how many people get in the decile. You can if you want. But you're basically dividing. So quartiles divides it into 4. Percentiles are divided into 100. Deciles divides it into 10. So not a big thing, guys. We're going to talk more about percentiles on the next slide. They just want you to understand that. Okay? All right. So calculating a percentile. Your percentile rank. Who has heard of percentile rank? When did you hear it?
Like, if you're getting tested, something like that.
Yeah, when you're ACT testing, that kind of thing, the report gives you your percentile. When you were a little kid, you got your percentile. What percentile you were in your growth chart? You guys remember that? No? Remember we talked about Tanner the other day? He did not make the percentile chart until he was 7. That's when he finally showed up. So, he was about 5. 2 standard deviations is about 5 percentile. Okay, so those things will come up when you take your little kids, maybe. Okay, so the number of values below x, and there's 2 trains of thoughts on this. This book says the number of values before x. Other books will say including x, up to including x. This one says below, so stay with that rule. So we're looking, what's the percentile rank of 10? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 below that. Divided by how many there are, and that's your percentile, 80%. So if you scored a 10, you scored better than 80%. You're in the 80th percentile. Okay? Make sense? So when you're looking at class ranks, you certainly want to be a higher percentile than a lower percentile. Okay. When you're looking at things like maybe weight, you would want to be at a lower percentile than a higher percentile. That's where you are, okay? All right. Everyone's got that little formula written? If you're looking at this cumulative frequency distribution O5, we want to know what score is at the 80th percentile. So again, this is a cumulative frequency distribution, so these are all percents. So we can go to 80, go across, hit our graph, and drop down, and it tells you what score you're at. So you're at about 1250, right? So if you're at the 80th percentile, then you scored approximately 1250 on the ACE or SAT. So those cumulative frequency graphs are kind of nice to do these things with the percentiles. Okay, finding the percentile of 34,000. So how many scores here? These are 25 scores, so I know I'm going to divide by 25. How many scores are lower than 34,000? So 1, 2, 3, 4, 5, 6, 7, 8. Did I miss any? Right? Are we good? We're not including 34. 8 divided by 25. So 32%. In the 32 percentile? That's wrong. Mental math is a great thing. 32%. That's a percentile. So I always say "ile" after that, because it's really percentile. All right? That makes sense? It's not a hard formula. All right, standard score. So we talked about z-scores the other day, and we approximated them on that bell curve. Now we're going to find actual z-scores with particular raw data. And again, we're not going to get into using the charts to find actual percents. We're still going to be estimating with that other thing on the bell curve, but this is what we're going to go to later, next chapter. So your z-score is your score, whatever the data entry is, minus the mean, divided by the standard deviation. And you find these the same with a sample as you would with population. Okay, what are we talking about here, sample or population? Sample or population, what do you think? What symbols do we have, samples or population? Population, right? This would be an X with a line over, this would be an S. Doesn't matter, same thing, okay? We ready? So the mean speed of vehicles along a stretch of highway is 56 miles per hour. Standard deviation is 4 miles per hour. Your measure speeds of 3 cars traveling along this stretch is 62 miles per hour, 47, and 56. So if you are above the mean, your standard deviation should be positive, yes? If you're below the mean, you should be a negative standard deviation. All right. Can we do one in our head here? What's 56? Isn't 56 at the mean? So how many deviations are you from the mean if you're at the mean? 0, okay? So 56 is 0 standard deviations, okay? The other ones we're going to do some work here. So 62 minus 47 divided by the standard deviation. It's not standard deviation, it's a z-score. Good Lord, I'm losing my mind. Well, it's still 0 standard deviations from the mean, but the z-score equals 0. Okay? What's 62 minus 47? Divided by 4. There you go, 3.75. That's pretty high, isn't it? Didn't we say most of the population is within 3 standard deviations of the mean? So if you're higher really than 2 standard deviations, that's a pretty unusual event. Okay, so 47, guys, let's go back. 62, what is the mean? We subtracted the 57, or 47. I was going to say, well, that's just weird that they gave you one. All right, 62 minus 56. 1.5, that's a little bit better. All right, 47 minus 56. Divided by 4. So this is a little bit more unusual because it's less than 2 standard deviations or more than 2 standard deviations below. Does that make sense? It's an easy formula. Okay? Anything above 2, it's going to be unusual. When they ask you that on Math Excel, you're saying, yeah, that's unusual. All right. So find these z-scores. Z-scores are used to compare two different types of people. If you had a 6-foot-tall woman and a 6-foot-tall man, you can't say, oh, well, they're pretty much the same. Right? I mean, they're the same height, but are they the same? Because this is 6 foot kind of tall for a woman. All right, so figure out the standard deviations. That's what you compare when you want to compare apples and oranges. Okay? So z-scores is what you need. Go. 6 foot is how many inches? Okay, figure out your z-scores. So, for the population of men, it's right around average. She is extremely above average. Okay? So when you're comparing apples and oranges, you've got to use z-scores. All right? Okay. That's it, guys. You good? Woo!